Hello and welcome. In this video, we are going to be making a top-down player controller. We're going to be doing this completely from scratch, and I'm going to show you how to make the controller itself, the animations for it, and we're even going to add a sprint button. There are timestamps down below if you want to skip to a particular part of the video. For this video, we'll be using the Godot engine 4.4.1, which is the latest release on stable as of the making of this video, and the entire project, including the art that I made for it, is going to be up on GitHub. I'll have a link down in the description so you can go in here and you can download the whole project for yourself. And with all of that out of the way, let's go ahead and jump right in. Alright, now before we get started with the player controller, I did set up a new project here, and there's a couple of things I want to do just to make it a little bit easier. And one thing I already did was set up the folder structure here. I just set up a couple of folders to make organizing things a little bit easier. And I'm going to highlight the sprites folder, and I'm going to bring over some sprites that I made. You are welcome to use these. I made them myself, and they'll be included in the download. With those sprites in place, I'm also going to create a 2D scene, and I'm just going to call this Area 1. And I'm going to save it, and I'm going to save it into the Scenes folder and into the Areas folder. Now, you may not have this folder structure. This is just what I prefer to use. You can use something totally different for you. I'm going to save. I'm also going to take the scenes and scripts folders that I made, and I'm going to favorite them for easier access. The next thing I'm going to do is I'm going to create a tile map. Now, I'm not going to go into too many details here. If you'd like to see a tutorial on creating a tile map, let me know. I'm just going to add a child node to Area 1. The main reason I'm doing this is because I want to be able to actually be able to tell when the player is moving, because otherwise it might be a little bit hard to tell. You could just drop a couple of sprites on the world and call it a day. I'm making a tile map just because I think it'll look a little nicer. Okay, so now that we've got our tile map layer, I just got to create a tile set and open up the tile set over here. I have a tile sheet over here that I imported, and you'll have access to this too if you download the project. I'm also just going to add some probability weights to the tiles here for randomization. And after a little bit of testing, I found that 40 works well for this one. This is just a simple grass tile map. And we're just going to go in here and we're going to paint a big square of randomized grass tiles. That's pretty good. And now when our player moves around, we'll be able to definitely tell that he's moving, since we've got all this little grass to compare his movement to. Alright, the next step is we are going to create a new scene. And this will be an other node. We are going to use a character body 2D to create the player. Create. I'm going to rename it player. And we're getting a warning. We need a collision shape 2D. There it is. And the collision shape 2D is going to need a shape, according to this other warning. And we're going to use a capsule. That's generally the shape that works best for player controllers. There are exceptions, of course, but I think in this case it'll work fine. And if we press F, we can center it on this. And we've got a little bit of a player checklist here. We're going to want a camera that follows the player. We're going to want a sprite that represents the player. And we're going to want to animate that sprite. So let's save the scene and start up with the camera. And we are just going to save this under Scenes. And the name player for the scene is perfectly fine. And we're going to add a camera 2D to the player. This is pretty simple. I'm just going to move it on top here. And I am going to change the zoom to 4. After a little bit of testing, I found that this worked well for the zoom level that I wanted with these given sprites, but you may have to play around with this. I'm also going to use position smoothing. I think it looks good. We're going to enable it. We're going to leave it at the default speed. And that's it for our camera. Because we're going to be moving the player scene directly, and the camera is a child of the player scene, we don't need to worry about any other kind of camera movement for a top-down game. So this is just super simple. Next thing on our to-do list is adding a sprite. So we're just going to go up here and select the player, add a child node, and we want a sprite 2D. And now that we've got that, we're just going to pick a texture here. And we've got the top-down player texture here that I imported. And now you can see this is also happening with the grass, but you can see this is kind of blurry because we're using pixel art. So what we're going to do is we're going to go into Project Settings. And what we want to do is go into Rendering here, into Textures, and change the default texture filter from Linear to Nearest. And this will correct all of the pixel art in our game, including the grass. If you're not using pixel art, you probably don't want to do that, but in our case we are, so this is our player sprite now, which obviously doesn't look perfect. What we need to do is create a region here with the texture, since this is a sprite sheet. If you're using individual sprites, this is going to be a bit different, and if you want to see a tutorial on that, let me know. But here we're going to be covering how to do this with a sprite sheet. So we're going to go into region here, and we're going to enable it. And everything kind of goes away. But what we want to do is we want to set up the rect here for the region. Now, I made these sprites and I know that they are 16 by 16. So you need to know what the height and width of the sprite sheet that you're using is for each individual sprite. So there we go. That's one sprite. And then as we move the region on the X and on the Y, you can see that we can kind of cycle through the sprite sheet here. I'm just going to put that back to 0 for now. And that is the second task on our to-do list here. Now the player has a sprite. And what we need to do next is animation. So there's a couple different ways to do this. I'm going to cover one way, but of course you're welcome to use whatever method you like. I'm going to go into here and I'm going to add an animation player. And I don't want it to be a child of the sprite 2D, so I'm just going to move that. And now that we've got the animation player, we need to start creating animations. So if I take a quick look over here at the top-down player image, I actually have 3 animations made here. We've got an animation for the player moving down, an animation for the player moving up, and an animation for the player moving left, which we're just going to flip to get the player moving right. Now, depending on the kind of game you're making, you might have different animations, you may have diagonal animations. This process can be extrapolated to use more animations. I am going to allow diagonal movement for the player itself, but we're just going to have the 4 animations. Before we get into the animations though, I'm just going to make a couple of quick changes here. I'm going to move the collision shape down to the bottom of the list so that we can always see it on top of the sprites. I'm also going to change the collision shape here in a second, but first I'm going to take the sprite 2D and I'm actually going to move it up a little bit. I like it when the feet are at the pivot point of the actual scene, so that's what we're going to do there. And now what we're going to do is take the collision shape and we're going to do a very similar thing here. And we're also going to shrink this considerably. Something along the lines of this, I think, will be good. Again, depending on the game you're making, this may be totally different for you. I'm going to make it so that the player's body and feet can kind of collide with things, but that the head doesn't. That way they can kind of look like they're in front of other things. And we're just going to save. And now we're going to go back to animation player. And we're going to hit animation here, new animation. And we're going to call this move down. And by down, I mean sort of forward. I'm calling it down because that's the direction and the screen that the player will be moving in. You can call these whatever you want. You just have to be careful with the naming because you will have to reference it later. All right, and if we look back again at the top-down player PNG, you can see that each animation has 4 sprites. So there are 4 frames that we need to put in here. So clicking back on animation player, we're going to make a 4-frame animation. Now I'm going to keep the animation length at 1, so since we want to divide that by 4, I'm going to change the snapping here of seconds into 0.25. And I'm going to turn on timeline snapping, and I'm going to zoom this in. You can zoom it in using this, or you can hit Control and mouse wheel to zoom in and out. And this is what we want, so we can see the 0.25 and the other one. So now with this on, you can see that it's going to snap. It snaps at 0, it snaps at 0.25, it snaps at 0.5, 0.75, and 1. So that's exactly what we want. So now we just need to create the animation. So we're going to go up here to Sprite 2D. And now that we've got the animation pane over here opened, you can see that we've got keys next to all of these. These are to create keyframes. And a keyframe is just something that will change with the animation. So in our case, as I showed earlier, what we want to do is we want to adjust the X and Y values here for the animations. So we want to create a keyframe at 0.25 that'll change the X value of our sprite. Looking once more at the PNG here, you can see that we want to change the X value because that's the one that's changing for any given animation. And the Y value represents different animations, but it may vary from sprite sheet to sprite sheet. So going back to Sprite 2D, the first sprite is actually going to be at X equals 0, so we'll just create a keyframe there. It'll ask us to create a reset track, which is totally fine. And I accidentally created that first keyframe over in 0.25. So what we can do is we can actually drag it down to 0 there. And actually we can't see 0 right now, so let's just move that over, and there it is. So you can see our keyframe is now at 0. So if you accidentally create them in the wrong timing, you can just drag them around and they will snap just like the timeline cursor. So that one's at 0, and now that we're at 0.25, we'll go back to Sprite 2D. We want to create another one at 16, because that's the spacing of the sprites. So 16, and then keyframe, and then 32, keyframe. And if you have trouble with math, you can actually use formulas here. So if you don't know what 32 plus 16 is, you can just say plus 16, takes you up to 48, keyframe, and that should be it. Because at the end here, we just wanted to loop and go back to that 0 sprite. So if we play this, we're going to see a couple of issues, but let's try it out. Okay, so 2 issues. Number 1, it's not looping. That's an easy fix. You can just hit the looping animation here. And the other issue is that even if we get it to loop, you can see it does funny things. That's not really what we want. It's sort of scrolling and interpolating the values. But we don't want the values to be interpolated. We want them to snap from value to value. So the way you can do that is you can go up to here and you can change the interpolation mode to nearest from linear. And then if you hit play, there you go. And that should be our animation working just fine. It looks a little slow, but we'll adjust that later. And now we need to create 2 more animations for movement. And it's going to be the same process. We're just going to have different values for X and Y. So let's create a new animation. This will be move up. And this will be the sort of back-facing sprite as they're moving up in the screen. So now we can create the first keyframe, and the X values are going to move in the same way, but the Y value we're going to want to change. We want it to be at 16 because we're working with the next animation now. And there is our back sprite, and create keyframe. Create a reset track, that's totally fine. And here it is on the 0. It's going to be at 0.16. So now that we've changed the Y value, we don't have to change it again for this animation. So the rest of the process will be exactly the same. We'll go to 0.25 and put 16 on X and keyframe. 0.5, 32 on X and keyframe. 0.75, 48, keyframe. And we want to make sure that this loops, and we want to change it to nearest. And let's take a look. There it is. Great. Stop, and then we're going to create another one. New animation. This will be move left. And we want to go from 16 to 32 on Y. And I'm just going to fast forward through this process because once you change that initial Y value, it's literally just the same thing again. There we go. And we're not going to create an animation for moving right because we're just going to flip that in code. You could create an animation for moving right and flip it here in the animation player instead of in the code, but I'm going to do it in code. It's just your preference. It's whatever you prefer to deal with. Not a big deal either way. But those are all the movement animations. We're also going to need idle animations. And in our case, we don't actually have idle animations here on the sheet. I'm just going to use the first sprite of each animation, and I'll call that an idle animation, even though there won't be anything animated. But I'm going to do it using the animation player just to keep things nice and organized and very much the same throughout. All right, so we're going to create a new animation, and it will be idle down for when the player is facing down. And I'm just going to go into sprite here, and I want to put Y back to 0 and X at 0, and I just want to create a keyframe, add 0. Reset track is fine. Now, if you actually had a sheet with idle animations, you would just create it the same way we just did the movement animations. Since I don't have that, I'm going to just change this to nearest put it on looping, and this idle down animation, I'm actually going to hit autoplay here so that when we load up the game, this will be the animation that shows. Hit that, and that's it for that. For the other two idle animations, I'm just going to speed through the process. It's the same thing again, I'm just changing the Y value depending on which animation I'm trying to create. And that should cover everything for all the animations that we need. But now we need some scripts. We're going to need two scripts, one for the player controller and one for the animations. So first we're going to go with the player controller script. I'm going to click on player and I'm going to hit the add script button here. And we are going to save this script over in the scripts folder. So I'm going to change this, go to scripts, scripts, player.gd, that's good. We're not going to use a template for this. And it's inheriting from character body 2D, which is just the type of node the player is, so that's fine. And here we are in the player script. The first thing we're going to do is we're going to give this a class name. Class name player controller. And this is just to make it a little bit easier to access this from other scripts. You don't have to do this part. It's just going to make some things a little bit easier. And we're going to save. And this script is going to be in charge of moving the player and taking into account any kind of variables associated with moving the player. For example, whether or not the player is sprinting and what direction the player is facing. The first thing we're going to need is a variable for direction. And this direction variable is just going to be a vector2. And then we're going to make our main function, which is going to be the physics process. And this is where everything's basically going to take place. Now, before we continue to add all of the logic here for the physics process, we need to make some input actions. So we're going to go to Project, Project Settings, and Input Map, and we're going to add input actions here. So we need one for when the player moves up, for when the player moves down, move left, oops, and move right. And we'll add a couple more here later, but for now this is going to be good. So I'm going to use WASD, but you could use the arrow keys, you could use controller mapping here. For now we're just going to focus on WASD, so we'll hit add event. I'll just press W. For down, we'll press S. For left, we'll press A. And for right, we'll press D. There we go, we're going to close this out. And we do need to keep in mind these names that we named these actions. Those are the names we're going to be adding here in the script. So make sure you type them right when you go to put them in the script, and make sure that you like these names and that they represent what you want for that action. So we're going to close this out and we're going to say if input dot is action pressed. Now we don't want to use is action just pressed for this, because that is better used for things that are like a one-time hit, for example a jump or something like that. Is action pressed is going to continuously check if you're holding down that button, which is what we want for movement. So is action pressed, and here we're going to put in quotation marks, and it should give us some autocomplete here. So you don't have to worry too much about typing it right if you use this system. So we're going to say move up and then colon. So if the action for move up is pressed, in other words, if W is being pressed, we want the direction dot Y to be -1. We're setting this vector2 based on the input of the player. -1 because in Godot, positive Y is this way and negative Y is this way, just like on a sprite sheet. So if the player is pressing W, we want to set the direction to be up, okay? Back to the script. Next up, we're going to do an else if. So elif, and we'll say input once again is action pressed, and this time we're going to say move down, because we're just working on the Y value of the direction right now. We'll get to the X value here in a minute. And here we're going to say direction dot Y is equal to 1. And then if neither one of those is true, we'll have an else statement that just sets direction.y equal to 0. So if the player is neither pressing W or S, we're just going to set the Y to 0. So next we want to do basically the same thing for the X direction. So we'll say if input dot is action pressed move right, then we'll say direction dot x is equal to 1. Much like the y, that's determined by the direction of Godot. In Godot, positive x is to the right, negative x is to the left. So since we're going to the right, we want positive direction here. And then we'll do elif input dot is action pressed move left, direction dot x equals to -1. We'll also have an else statement here where we can zero out the x of the direction if there's no input. And that should be pretty much us setting our direction variable. I'm just going to make a couple comments here. So this will be sets the y value of the player input. I'm just going to copy this, put it here. I'm going to say sets the x value of the player input. Now this isn't actually doing anything right now. The only thing we're doing is we're setting a direction variable that we created based on the input of the player. But we need to actually do something with this direction variable. So if we control click on character body 2D, we can actually see all of its variables and functions, and it's got a velocity variable here, which is also a vector 2. This is what we're going to use to actually move the player, along with the move and slide function. So what we need to do is we need to set the velocity vector with the direction vector. So we'll say velocity equals to direction multiplied by delta and multiplied by 200. Because we're multiplying by delta, which is a very small value, I'm adding this extra 200 in here just to increase the speed. We're also going to multiply this by a move speed, which will be an export variable, because this way we can easily adjust the speed of the player without having to go into the code. And I'm just going to initiate it as 20. So we're going to take this variable, we're going to multiply it here. So this is going to be our velocity. Now that we've set the velocity, we can actually call the move and slide function, which is again a part of character body 2D. And we should be able to move our player now. But before we do, we need to go back to area 1 and we need to actually add our player to the scene so that we can actually move around in the scene. So here in area 1, we're going to use this link icon, which is to instantiate a child scene. We're going to use the player. And now we can hit play, and it's going to ask us to select a default scene. We can just select current, because we want area 1 to be the default scene. You can change this later. You can also hit select if you want to select a specific one. And here we are, we're starting up the game. And here's the game. And I can use WASD to move around. And my player is in that default animation that we set. And you can actually see that it's working. Now we do have a current issue, which is that if I hit a combination of keys, for example, a diagonal movement, you can actually see that I'm moving faster diagonally than I am when I hit one of the 4 cardinal directions. Now the reason for that is that the direction vector is not normalized. So I'm going to stop this, go back to the player script, and we just need to normalize this direction variable, which is really easy. You just say direction equals to direction dot normalized. We could just normalize it right here during the multiplication, but the nice thing about doing it this way is that if we use the direction for something else, it'll already be normalized. So we'll just do it this way. And this just makes it so that it does not have values that are greater than 1. I'm just going to save that and we can try this again. Hit play. And there you go. Now it's working as expected. So that's pretty much our character controller basics. We need, of course, to add the animations, and I think we're also going to add a sprint button. Alright, so back in the player script, let's go ahead and add a sprint function. So what we need to do is we need to first go into the project settings and input map, and we're going to add a sprint action. And add a key. I'm going to use shift. There we go. And back on the player script, what we're going to do is add a sprint variable up here as an export variable so that we can tweak it in the inspector like the move speed. And I'm going to call this sprint increase. And this will be the amount of speed that we want increased by holding down the sprint button. I'm going to set it as 1.5 because this is actually going to be multiplied into the move speed. You could make it additive instead of multiplied. That's entirely up to you. And then we're going to have another variable here called sprinting. And this will be a Boolean, which will initiate as false. And this variable will just be used to tell other scripts whether the player is sprinting or not. And then another variable here called sprint multiplier, which will initiate as 1.0. And this is what the actual value that we're going to be multiplying to determine whether sprinting is increasing the move speed or not. So sometimes it'll be 1.0, sometimes it'll be 1.5, depending on whether we're holding down that button or not. Okay, so after this x value is set, but before we multiply into the velocity variable, we're going to set a new if statement. This will be if input dot is action pressed, and we want to look for the sprint action. There it is. And what we'll do is, if the player is pressing shift to sprint, we'll set sprinting equal to true. Otherwise, sprinting is back to false. And that doesn't do anything. We actually need to set the sprint increase. So in this case, we are modifying the sprint multiplier here. So sprint multiplier is going to be equal to the sprint increase if the player is sprinting. Otherwise, we just want it to be set back to 1.0, which was its original value. So if we change this value in the inspector to say 2 or 2.5 or whatever, that'll change right here too. So whenever the player is sprinting, it'll go faster. And then we want to actually take this sprint multiplier, which is the value that we're changing, and we want to multiply it into the velocity calculation. We're going to save this and we're going to try it out. It should be working. So I can move around like normal, but if I hold down shift, you can see I'm faster. And if I'm over here looking at the player inspector, I didn't try this before, but if we change the move speed, for example, we want to set it to 10. See, it's much slower. And this is the value of putting these in the inspector. But let's say we want to take the sprint increase and set it up to 3.0. So our move speed's really slow, but then our sprint is much faster. And then let's say, we could even change it to like 10. And there we go. We're sprinting very quickly, but then we're moving very slowly. And this is why I like using these export variables like this. I actually like the default values I've chosen here for sprinting and movement, but you can tweak these until you get what you want. I'm actually going to make a quick little change before we make the next script. I would prefer for this to be called player controller. You don't have to do this. I'm just kind of picky with what I name things. But if you right click it, you can hit rename, and then you would say player controller there. And that should be good. So I'm just going to save. And looking back at the player scene here, I'm actually going to make a new node. So I'll hit plus, and I just want a node 2D. And I'm only doing this for organizational purposes. You don't have to do this, but I like keeping all of my animation stuff together. So I'm going to call this node animation system, without a space actually. And I'm going to put the animation player and the sprite 2D as children of this node. And this is where I'm going to put the animation script. Again, you don't have to do this. You could put it right on the animation player if you wanted, for example, but I just like to keep this kind of organized. It's nice especially if you're working with something that might have multiple animation players or multiple sprites. So I'm just going to hit plus on the script. And I'm going to call it animation system, that's fine. We're going to put it in the scripts folder. Save. And this is going to be our animation script that's going to handle all of the animation switching with the player. So this script is going to need access to the player controller, and there's a couple of ways that you can give scripts access to things. I like using export. So we're going to use export var player controller, and it's of type player controller because we gave it a class name. But this script is also going to need access to the animation player and the sprite 2D. The other way to do this is you can actually control click and drag these over here. So if I control click, for example, the sprite 2D and the animation player, I can throw them on there, and then it says on ready var animation player sprite 2D, and it has a reference to that. Now, you can do this and it looks a lot easier, but they both have their pros and cons. The problem with doing the export is that you have to actually manually come on here on the animation system and assign the player controller. Okay? If you forget to do that, it's not going to work. I forget to do it all the time. It's not a big deal. You just go back and you select it on there. The problem with doing it like this, though, is that if you move these to a different spot in the scene, like let's say I did this, then this wouldn't work anymore. And so that is very dependent on the way the scene is structured. Whereas if I move the player controller once it's an export variable and once it's set over here, it's still going to work just fine, which is why I prefer this system. I'm going to use both for the purposes of this tutorial so that you know how to do them. But yeah, I've been asked this before. A lot of people do this. It's totally fine if you're, very organized and you don't tend to move your stuff around. I just prefer to do the export system. I don't know, maybe it's because I originally started working with Unity before and that's kind of how it works there, but yeah, both ways work. Just be mindful that both ways have their nuance. So with that out of the way, we're going to want to have the process function here. We're not working with moving stuff around, so we're not using physics process, we're just using process here for animation. And we're basically going to have two main areas of the process function. We're going to have one for when the player is moving and one for where the player is not. So we're going to say if player controller dot velocity dot length is greater than 0. So this is just saying that if the velocity vector of the player controller has any amount of length, that means the player is moving, they have a velocity, then we're going to play movement animations. Just putting in a comment here. Else, if there is no length to the velocity vector, then we want to play idle animations. And now we just need to work out the logic for each one of these, and we're going to do that by checking the direction vector as well. Rather than checking the direction variable directly though, we're actually going to go back to the player controller script, and we're going to create a facing system. The reason for this is that we actually have different idle animations depending on the last facing of the player. And when we let go of the input, the direction all gets set back to 0. So there's no way to see what direction the player was facing after the player lets go of the input keys. So what we'll do is we'll create an enum up here. And we're going to call the enum facing. And we're going to create 4 directions for facing. Up, down, left, not lefty, and right. If you haven't used enums before, they're really great for when you just want to pick one of several different options. Really good in this case because our player isn't going to be facing more than one direction at a time. And the convention is to use all capital letters for enum values. And what we'll do is now create a variable called player facing, because up there I'm just creating the enum, but here is where we actually create the variable that we're going to be changing, and it's going to be of type facing. So what we'll do is when we take a directional input, we're going to change the player facing based on that directional input. So here we can say player facing equals facing up. It's actually facing dot up. And here we'll say player facing equals facing dot down. Here we'll say player facing equals facing dot right, and player facing equals facing dot left. And now what we've got is that whenever the player uses an input, the facing will get set, but it won't get reset the way the direction does when the player lets go. So we'll always know what the last input was from the player to be able to do the facing. And this is also going to be useful if we want to add something like an interaction system where the player can interact with whatever they're facing. Okay, so back on the animation system, we're going to start adding logic here for checking the player's facing and playing the appropriate movement and idle animation. So we'll do an if statement that checks the player controller dot player facing, and we want to compare the player facing to also the player controller facing, because that's where the enum is initiated, down. So in this case, if the player is facing down and moving, then we want the animation player to play the move down animation. And the rest of this logic is going to be exactly the same. So I'm just going to speed through it. We're just checking the facing of the player and then comparing it to the enum facing value, and then playing the appropriate animation for whatever the facing is. And the only difference down here is going to be that instead of playing the move animations, we're going to play the idle animations. So let me type this out and then we'll go over it. Alright, so here's everything. So we've got 4 different animations for move and 4 different animations for idle, but really we've only got 3, because if you think back to our PNG, we only have left facing on this sprite sheet, we don't have right facing. If you did have right facing on your sprite, you wouldn't have to do this next step, but since we don't, what we have to do is that whenever we want to face right, whether we're moving or idling, we need to flip the sprite 2D horizontal value. And that's why we've got this extra line here, and that's also why we have a reference to the sprite 2D. But we don't want it to always stay flipped, so what we actually need to do is we need to take this line and copy it. We're going to copy it up here. So what we're doing with this is every frame we're making sure that the flip horizontal is set to false. This way the other animations don't flip. But whenever the player is facing right, we're going to make sure that flip value is set to true. So let's try this out. We're going to hit play, and we're going to move the player around. And yeah, sure enough, the correct animations are playing. And you can see if I let go of the movement keys, the player stays facing whatever direction they were facing last, which is exactly what we want. And we're almost done here, but there's one more detail I'd like to add. I was thinking that the animations felt a little bit slow, so I'm going to go to the animation player here in the hierarchy, and I'm going to set it to 1.6. That will speed up the animations a little bit, but we're going to do something just a little bit more interesting here. And this is totally optional, it won't affect the actual functionality of anything, but I just think it's kind of cool. So we're going to add a couple of variables. We'll have a variable for default animation speed. And we're also going to add the ready function, which is where we're going to set this new variable. And what we'll do is we'll say that the default animation speed is going to equal the animation player dot speed scale, which is this value over here. So whatever we set in the inspector is going to get set to this value right here in the script. And now what we're going to do is we're going to do one more check here. So at the bottom of the movement check, we'll have a different if statement. This is a new if statement, not an else if. So we'll say if the player controller dot sprinting. So this is checking if the player controller is currently sprinting. Then what we'll do is we'll say the animation player dot speed scale is going to be equal to the default animation speed plus the player controller dot sprint increase times 0.5. And I worked this formula out with these values as I was experimenting. So basically we're just taking the speed scale and we're adding the player controller's sprint increase multiplied by half. This is going to make it so that the animations play just a little bit faster when the player is sprinting. And I think this is a nice little detail to add so that it doesn't always have the same walking animation. Now maybe you've got a walking and a running animation in your sprite sheet. You may not need this, but since we don't, we're going to do it. And we've got an else statement here where we are just going to take this and say default animation speed. So if the player is not sprinting, we're just going to set it to here. Now what we don't want is to speed up the animation for the idle animations. Technically, if we do, it won't matter because we don't actually have proper idle animations. They're just single sprites. But if you did have idle animations and you left it like this, what would happen is that then your idle animations might be too fast. So what we'll do is we'll just, at the end of this else statement, we'll say that the speed scale should just be set back to the default value. And let's go ahead and save this and let's try it out. And let's see, if I sprint, you can see the animations get just a little bit faster than if I slow down. And that's exactly what we want. I think that looks pretty good without having to do a lot of extra work making new animations. I think that's a neat little feature to add. And another cool little piece of functionality for that is if I actually change the sprint increase, like let's say I want to put it at, 6, the animation will also speed up even faster. So whatever I set the sprint increase to, it's going to sort of react to that. So that's a pretty nice little feature. And that more or less sums up our player controller. And this was a bigger tutorial than I usually make on the channel, but I wanted to make an entire project that was at a good starting point for a top-down game. And I thought maybe we can add more features to this depending on what people are interested in. So feel free to let me know in the comments what you may want to add to this game. And if you want to come by the Discord and talk about it there, or if you're having any kind of trouble with this tutorial, make sure you come by there. I'm always happy to help. And there's a bunch of helpful people there too. If you want to see more videos like this, make sure you subscribe. And also, if you liked this video, hit the like button, leave me a comment. That really helps out a lot. And thanks so much for watching.